Good morning, ma'am.
Good morning. How are you?
Fine, ma'am. Ma'am, how are you?
I'm fine, thank you. Hello, Nimra.
Assalamualaikum, ma'am.
Walaikum salam. How are you?
I'm good, ma'am. What about you?
I'm fine, thank you. Hello, Amna.
Hello, ma'am. How are you?
I'm fine. How are you?
Good, ma'am.
Hello, Halima.
Assalamualaikum, ma'am.
Walaikum salam. How are you?
I'm fine, ma'am. How are you?
I'm fine, thank you. Hello, Sahib.
Hello, ma'am.
How
Hello,
are you?
ma'am. Good morning.
Good morning, Fahad. How are you?
मैम मैं ठीक हूँ अल्लाह का शुक्र है मैम.
Okay, so let me share the text. Let's see. This one. Yeah, okay. Mm, 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 mm. Okay, so as you know that we have completed chapter number 4. We've already completed this a few days ago. Now we are practicing the different concepts and applying those concepts to solve problems, right? So this is also helping you prepare for the upcoming assessments. So let's look at vectors. We know that we can make vector diagrams and how we can use these diagrams for addition, subtraction, and so on. And another important concept that we use when dealing with vectors is the concept of trigonometry. So we are familiar that these trigonometric ratios can help us find the components of a vector, and then later on we can use them for addition and vector manipulation. So in this case, we use this Pythagoras theorem, right? You remember the Pythagoras theorem, right? According to this theorem, you have a right-angled triangle like this, where one angle is a right angle and one angle can be represented by theta, for example. Then you can, the vertices are labeled with A, B, C, and opposite A, this is, notice that the vertices are labeled with capital letters, and then you have these small letters. The capital letters are points and the small letters are the lengths of the sides. So you can see that, for example, opposite the vertex A, you have a line which has a length equal to small a. Similarly, opposite the vertex B, you have a line that has a length equal to small b. And similarly, opposite the vertex or the point C, you have a line that has a length which is called or represented by the letter small c. Now, this line which is opposite to the angle theta is called the opposite side. Opposite side, or it's also sometimes called the perpendicular. This line, which is opposite to the right angle, is called the hypotenuse. And this line, which is opposite to B, is called the, this is called the adjacent side. Adjacent means it's beside this angle theta. So everything is happening with the reference to the angle theta, right? Adjacent side, or you can call it the base. I'm emphasizing on this these terms because when you will be actually applying these concepts, you will not have a triangle always in the form that you're looking at here. It might be rotated. I also, while studying this chapter, I also pointed out some cases in which the triangle was rotated. So it's possible the angle theta is somewhere upwards or sideways or something like that. So you have to identify the triangle, and then you have to identify which side is which, and then you can apply the trigonometric ratios. So sometimes if it's difficult to identify the perpendicular, then you can try to look for the opposite side, the side opposite to the angle. One angle is the right angle, but then the other angle, you consider that, and you consider the angle you're going to use for the trigonometric ratios, and then find the side opposite that. Similarly, it's not all, the base is not always, will not always be downwards. Like, it's easy to see that the base is downwards in this case, but again, if this triangle is rotated in some other way, then you might be finding it difficult to identify the base. Then it's easy to identify the adjacent side to the angle theta. This will help you again apply your ratios correctly. Okay, so these are points that should be noted. Again, we talked about directions. You can define them in terms of north, south, east, west, and you can also define them in terms of the Cartesian coordinate systems using the xy axis and then the angle that it's making with the xy axis. So these concepts have already been discussed, and we can now apply them. And before applying them, we can also revise the concept of components of vectors, because this is important and it helps us solve problems related to vectors. So this is the concept I'm talking about. Like I've always said, that you can only join the meeting with your proper name. You cannot join the meeting if you're not showing your proper names. Now, there's someone in the waiting room with the name of Galaxy Prime. You know, I cannot add this person. This person has to show their proper name. You know, we've done more than half of the course. I think everyone should be aware of this. And it's very easy to change your name even during a meeting. You know, you just go to the participants list, right click on your name, and you can immediately type whatever name you want to display. Even if you're using your friend's device or your sister's or brother's device, you can always change the name when you join a meeting or even during the meeting. So you can just right click the icon and you can change the name. Okay, so I have been talking about. Okay, so coming back to components of vectors. So this is how we find the components of a vector. You can see that if you have a vector C, for example, the x component is normally represented by a subscript x and the y component is represented by a subscript y. Okay, and also you can see in this case we have shown two diagrams. One shows the triangle in the standard form that we see, and the second one shows a diagram of a triangle where it is not in the standard position, rather it's in a rotated position, as I mentioned before. But again, the same rules apply, but you have to correctly identify which angle and which side means what. Okay, so that you don't make a mistake when you are applying the formulas. Okay, so for the vertical component, right, the y component is the vertical component. Again, this is with reference to the coordinate system that we have, x and y. So if you want to find the y component, you multiply the hypotenuse with the sine of that angle. If you want to find the x component or the horizontal component, you multiply the hypotenuse with the cosine of that angle. Okay, so these are the simple formulas that we use, and we can find Cx and Cy. So when we find the horizontal and vertical components, then we can also find the angle, if we have to find the angle, by dividing the vertical component with the horizontal component. And if you want to find the magnitude of the resultant is found by using the Pythagoras theorem. According to the Pythagoras triangle that we saw, c squared was equal to a squared plus b squared, or c is equal to a squared plus b squared under the rule. So this is the same thing that we're doing here. We also did that problem in the beginning. Now you can see this concept again illustrated in this diagram where you have two vectors A and B and you're being told to add these vectors. These are two independent vectors A and B. So the first step is that you will draw a diagram in which A and B are joined according to the head to tail rule. Then you will make the rectangular x and y components for each of these vectors. And then you will see that the resultant vector, which we can call C, for example, goes from the tail of the first one to the head of the last one, according to the head to tail rule. So it goes from here to here. So this is C, like you can see here. And then C can also be divided into its horizontal and vertical components, and you can get Cx and Cy. Then the formulas that we just talked about, you can use them to find Cx and Cy. So Cx will be the sum of the horizontal components of vector A, which is Ax, and the horizontal component of vector B, which is Bx. And Cy will be equal to the sum of the vertical components of the vector A and the vertical components of the vector B. And so when you get Cx and Cy, if you want to find the angle, which in this case has been represented by psi, theta and phi are already known. So you can find the angle using tan theta is equal to Cy over Cx. And then theta will be equal to tangent inverse Cy over Cx. And then when you want to find the magnitude, you again use that C squared is equal to Cx squared plus Cy squared. So the same formulas that we've studied already. And doing all this, you can then write your answers in the form of a table. You have found Ax, Ay, Bx, By, Cx, Cy, and whatever else the problem is talking about. Now let's use the concepts that we studied so far to solve this problem. So please solve this problem yourself, each of you. And when you've solved it, tell me your name and explain it to me, and I will give you a point for this. Meanwhile, I'll take your attendance, okay? So, okay, Hassan Ahmed is absent. Okay, Fahad Ahmed.
Present, ma'am.
Yes. Fahad Ahmed के बाद you have Aisha. Aisha is absent. Ali Musa. Ali Musa is absent. Mahnoor. Nimra.
Present, ma'am.
Yes. And Azad Asad. Sayyid Azad Asad. Farooq Ahmed.
Present, ma'am.
Okay. Muhammad Awais Khabar Gill is absent. Laiba is absent. Sahib.
Present, ma'am.
Okay. Ilya Shafkat.
Yes, ma'am.
Amna Maha.
Present.
Nashra. Nashra is absent, I think. Yes, Nashra is absent. Aruba.
Present, ma'am.
Okay. Halima. Nawab Sadiq.
Present, ma'am.
Sumavi Tahir is absent. And Saul Rafakat. Saul Rafakat, you've just entered the class, so you just came for the attendance, right?
नो मैम मैं पहले ही आना चाहता था वो मेरा नाम चेंज नहीं था और जिस वजह से 10 मिनट उधर ही कंज्यूम सॉरी फॉर दैट
प्लीज आप नाम चेंज करना सीख लें, इट्स सो इजी. ठीक है
मैम वो मैं फोन पे ले रहा हूं इस वजह से नहीं तो कंप्यूटर पे होता.
ठीक है. Okay, so let's come back to the problem that we were talking about. ठीक है. So we are talking about an explorer who's walking 30 kilometers, who walked 30 kilometers due south. So when we talk about these directions, okay, we can draw them here, north, south, east, and west. So he walked initially 30 kilometers towards the south. So you can use 3 divisions here like this maybe. So 1, 2, 3. Then 20 kilometers due east. So 20 kilometers can be 2 divisions, and you can have it here. So this is 20 kilometers. And then finally, in a direction of 60 degrees north of east, he walked 50 kilometers. So if you make an angle of, so this is east and that is north, and you make an angle of 60 degrees. So he walked something like this. Again, 550. 1, 2, 3, 4, and 5, right? Towards 60 degrees north of east. Okay, so this is what the statement of the problem is. Now we have to use the concept of addition of vector components method to calculate the distance of the explorer from the starting point. This is the starting point to the ending point. So we have to find this. Okay, we can call this whatever we like. We can call this A, we can call this B, we can call this C, and then we can call this the resultant R, let's say. So this is what we have to find. Now, how are we going to do this? Would anyone like to explain? You will get a point for
Ma'am, can you repeat the question?
naam bolo. What's your name?
Amna.
Ji Amna, yes.
मैम मैंने कहा आप क्वेश्चन रिपीट कर देंगी क्या आप
Amna, you can, I have shared my file with you. The question is in front of you. Can't you see it? Amna?
Ma'am,
मैम
I am sharing the text with you. And you can see the question there. In fact, you also have your own files. Haven't you taken the printouts, as I said in the beginning of the semester, that whatever chapter we are studying, please keep the printout or the photocopy with yourself so that you can always refer to it.
नो मैम अभी नहीं निकलवाया आज निकलवा लूंगी
We've already finished the chapter and you have not even taken your printout. You know, it means you cannot follow properly if you don't have the printout with you. And that's why I uploaded these chapters at the beginning of the semester, and I told you to get them either from the photocopier or from anywhere else. You have the soft copy also. But it's always convenient to have them in printed out, right? So you cannot, tell me, please open to so and so page. I want to see what's written on that page. Actually, you have these pages, right?
यस मैम
Yes, anyone else who would like to answer?
ma'am, Elia this side.
G. Elia, yes.
Ma'am, I think इसमें perpendicular hypotenuse और वो base का formula use करेंगे जब.
Okay. So, Elia, you can again, we can see this, the diagram that I drew for you here has been drawn accurately over here. You can see this, है ना? इस यहाँ से explain कर दो. It's easy to explain it from here. So the explorer started walking from the point here, okay, which we can take as the origin. He walked 30 kilometers south. This has been represented by the vector v1. So you can use whatever symbols you want. Then he walked east. This has been represented by v2. Then he walked 60 degrees north of east. This is represented by v3. And we have to find the resultant, which is from the starting point to the finishing point, and this is R. Ji Elia, आगे explain करो. Elia,
Yes, ma'am.
आगे explain करो, then you get your point.
मैम मैंने कहा था कि वो शायद दूसरा फॉर्मूला यूज होगा.
दूसरा कौन सा?
वो साइन, वो जो ये हम यूज करते हैं साइन ए और साइन बी ए
हाँ, तो वो
डिवाइडेड बाय
यूज
सी.
होंगे, लेकिन कैसे यूज होंगे? You have to explain that, ना? सबसे पहला स्टेप क्या है? What's the first step?
मैम इनके हम ये सिंपली
अभी मैंने आपको ऊपर बताया भी था, समझाया भी था। देखो हमने ये इस एग्जांपल के साथ,
कंपाउंड्स को
हाँ इस एग्जांपल को
कंपाउंड्स
फॉलो
को
करो ना। क्या करना था हमने? पहला स्टेप क्या था?
ज्वाइन करना था मैम,
वो तो कर
हेड एंड
लिया,
टेल रूल
वो
कर
तो
लिया।
वो तो कर
उसके
लिया।
बाद draw in the components of each.
हाँ, components of each. यहाँ पे A था, we determined the components of AX and AY. You just don't have to draw it, you also have to calculate them. Okay. Similarly, we had B, we determined the components BX and BY of B. उसके बाद when you come to this problem, यहाँ पे we have V1, V2 and V3. So what do we do?
मैम इनको प्लस कर देंगे,
कैसे प्लस कर देंगे?
इनकी वैल्यूज
नहीं, पहले स्टेप होगा you will find the components of each vector. Okay. पहला स्टेप ये था, you draw the diagram. Okay, this is step 1.
ओके
Step 2 क्या है कि you have labeled the vectors. Okay, this is step 2.
ओके
Step 3 क्या है कि you're going to determine the components of each of the given vectors. Okay, ये step 3. You determine the components of each vector. ठीक है? तो components में दो तरह के, you have two types of components. You have the x components and you have the y.
एंड वाई, एक वाई कंपोनेंट.
Okay, so you have to find x components. X components are v1x, v2x
v2x
and v3x.
v3x.
v1x is equal to what? v1x, the formula for v1x will be
v1 plus v2 शायद.
नहीं ये लिया.
A opposite side divided by hypotenuse.
We have the formula there. ये देखो ये v1x क्या होता है यहाँ पे ऊपर. We have seen this formula. So you see ये देखो, ये देखो, एक मिनट, ये देखो. The x component is equal to the hypotenuse multiplied by the cosine of that angle, and the y component is equal to the hypotenuse multiplied by the sine of that angle. Okay. Now using this formula, we can come back. So we come back here and we use these formulas that I've just shown you. So
मैम बुक नहीं शो हो रही.
book नहीं show हो रही है आप लोगों को. Wait,
नो मैम.
Yes मैम, नहीं हो रही.
I'll check that again. अब हो रही है.
Yes मैम.
Yes.
Okay, so what did I talk about? I was talking about the fact that we have to find the components. ये नजर आया था? I talked about step 1 where you have to draw the diagram for the statement of the question. Okay, according to the statement of the question. The second step was you label the vectors. So we called the first one v1, the second one v2, the third one v3. You can use whatever symbols you like. Okay. And then what we have to find is the resultant R. So R, we've used the symbol R for the resultant. Okay. Now, the third step is, as we just said, is that you have to find the components of each vector. Okay. So you have to find, again, when we talk about components, we're talking about x components and y components. So we have to find the x and y components of v1. We have to find the x and y components of v2. We have to find the x and y components of v3. So we can start by the x components. So when we talk about x components, then we have to find v1x, v2x, v3x. Now I was asking you the formula for these. So what is the formula for v1x? I just told you. The formula for v1x is? You're not studying at home, are you? It will be V1 cos of theta, right? According to a few pages back where we discussed these formulas. You remember? We discussed these formulas here, right? How you find the components of a vector and the formulas that you use, okay? So for example, for C1, Cx, you use C multiplied by the cosine of that angle, and for Y, you use the sine of that angle. So using these formulas, we come here, this is equal to V1 cos theta. This is equal to V2 cos theta. This is equal to V3 cos of theta. Now, what is theta? We have to determine what is theta in this case. The first vector is making an angle of 90 degrees with the x-axis. So in the first case, this is cos of 90. So V1 cos of 90. In the second case, we see that it's making this vector V2 is along the x-axis, it's parallel to the x-axis, so it's making an angle of 0 degrees. So in this case, this will be 0. And for the third case, it's making an angle of 60 degrees. So in this case, this will be 60 degrees, okay? Another thing we have to notice is that this.
मैम प्लीज दोबारा बता दें कि V2 0 कैसे है? वो 90 और 60 की तो समझ आ गई है।
अच्छा, ये कौन बोल रहा है?
मैम आमना।
Amna, okay. So when you look at your x, y, and z axis, this is x and this is y, okay? A line, x-axis, a line that's parallel to the x-axis is making an angle of 0 degrees. Amna?
Yes, ma'am.
x-axis के साथ 0, और अगर वो ऊपर बना दे या नीचे बना दे, एंगल तो 0 ही रहेगा ना? ठीक है ना? ठीक है आमना?
Yes, ma'am.
Direction तो 0 ही रहती है ना, so therefore this V2 is along the x-axis, that's why it's 0. Okay?
Okay, ma'am.
हाँ, और दूसरी बात आप नोटिस करो कि ये V1 जो है, आपको पता है पॉजिटिव y axis ऊपर is upwards and negative y axis is downwards. This one is downwards, that's why we have the minus sign here. You can see this minus sign. ठीक है?
Yes, ma'am.
अब इनकी you can put their values. So V1 is 30. So this is 30 and it's minus because it's downwards. Multiply by cosine of 90 and you get the answer. The second one is 20. 20 multiplied by the cosine of 0 and you get this answer. The third one is 50 and 50 multiplied by the cosine of 60 and you get this answer. So you have, this is V1x, this is V2x, and this is V3x. Okay? ठीक है?
Yes.
So these are the x components. The next step is the y components. In the y components, the only difference is that you're going to replace the cosines with the sines. ठीक है? आप इनके साइंस ढूंढ लें. इसके दो तरीके हैं, है ना? इन्होंने एंगल चेंज कर दिया है. I would advise you कि आप साइन ही यूज कर लें, आपका सेम आंसर आ जाएगा. अगर आप इन्हीं एंगल्स के, आपके लिए आसानी रहेगी. ओके, सो अगर आप साइन 90 ले, साइन 90 इज 1, इन्होंने cos 0 ले लिया क्योंकि ट्राइंगल में दो एंगल्स होते हैं ना. एक दफा उन्होंने ये वाला एंगल यूज कर लिया, एक दफा ये वाला एंगल यूज कर लिया. लेकिन मुझे लग रहा है कि आपके लिए आसान होगा अगर आप कोसाइन की बजाय इसमें साइन ले लें. दोनों मेथड्स ठीक है. समझ आ रही है ना?
Yes, ma'am.
हाँ, तो आपको ये भी याद होना चाहिए कि ये बड़े सिंपल रेशियोज है. cos 0 जो होता है दिस इज इक्वल टू 1, cos 90 जो होता है दिस इज इक्वल टू 0, जबकि साइन में ऑपोजिट हो जाता है. साइन 0 जो होता है दिस इज इक्वल टू 1 एंड साइन 90 जो होता है दिस इज इक्वल टू, सॉरी, ये 0 होता है और ये 1 होता है. सो यहाँ पे you can either use this, you can change the angle or you can change the ratio. So if you want, you can use sine of 90, आंसर सेम आता है. ठीक है? And similarly you have दूसरी केस में you have sine of 0, again the answer comes out to the same. And तीसरे केस में sine of 30, so sine of 30 is equal to the cos of 60. So वो भी आंसर आपका वही आ जाएगा. So you can, this is V1y v2y, इसमें कंफ्यूज नहीं होना, okay? दोनों methods ठीक है, जो आसान लगता है you can use that, okay? So now you have found the x components of the vectors of the given vectors and the y components of the given vectors. Now we can again use this formula that the resultant in this case was C. Now we are representing it by R. Okay, so the resultant, we find the x component of the resultant and we find the y component of the resultant. The x component of the resultant is equal to the sum of the x components of the given vectors, and the y component of the resultant is equal to the sum of the y components of the given vectors. Using this same concept and formulas, here we can write the x component of the resultant and the y component of the resultant. This is equal to v1x plus v2x plus v3x, and you get your answer. In this case, you get v1y plus v2y plus v3y, and you get your answer. Now you have the x and y components, then you can use the Pythagoras theorem. Previously, we were writing c squared is equal to cx squared plus cy squared. In this case, we're using the symbol r, so r is equal to this. You can put the values and you can determine the. Now you have the magnitude. For the direction, we use the formula that tan theta is equal to cy, the vertical component over the horizontal component. Again, in this case, it is tan theta is equal to ry over rx, and you get this. And then you take the inverse to get theta. Theta is equal to the tangent inverse cy over cx, and you get this. And this is your answer. Okay?
Yes, ma'am.
Okay. So please practice this and practice it on the same day. If you wait for 1 week or 2 weeks till you have the exam, by that time you will have forgotten the discussion we had in class, and then you will have to spend more time to understand it, or you might get confused altogether. So it's best you go and practice it on the same day that you studied it.
Were we not supposed to measure the distance?
This is Sahib.
Yes.
Measure which distance?
Like, what was the distance from point A? Like, what was the distance of resultant?
There are two methods of doing this. One is known as the graphical method. The second is known by the method of components of vectors. The if you want to use the graphical method, then you will have to take a graph paper and draw these vectors according to scale, like we draw an actual graph. And then you will have to measure it and multiply it by the scale and then give your answer. And sometimes that becomes too complicated. It can be done for simple vectors, but sometimes if you have more vectors and more measurements and so on, it becomes more complicated, and this method is more accurate. So at this time, we're using the method of component of vectors. Both methods are correct. You can use any method you like. But if the question asks in particular about the components, you see in this question, they have particularly said using the vector component method. That's why we're doing it. Also, the vector component method is more accurate, because when we are manually measuring, we always have an error, right? So you can, if they don't give you any particular method, then you can use the graphical method. You can draw it on a graph paper and measure it with a ruler and then give your answer. Or you can, I think this method is also quicker. I would prefer this method. Okay. But if they have in particular asked you to use a specific method, then you use that method. Okay.
Right.
Right. Okay. So please remember to practice this today. Otherwise, you will again forget it, and then it will be difficult for you when you have to prepare for your exam. Okay.
Excuse me, ma'am.
Yes. Naam bataya karo.
Sahib.
Yes.
I feel like this is being more mathematical, like for underlevel course.
The level of mathematics is school mathematics, beta. All of you have done this kind of mathematics in class 7, class 8. It's not a difficult mathematics. You know,
but I was expecting more like conceptual things.
Sahib, this is, you cannot do physics without mathematics. And the kind of mathematics you're doing here is simple algebra, which you have already done in your school in class 7 and class 8. I'm sure you can go back and look at your books from that time and you will see these formulas there. Okay. Right. So now, again, like we are just revising the chapter. We've already finished it. Another concept that we started in this, I cannot give you a memorization. Okay, write the Newton's second law of motion. That's not the kind of question I'm going to give you, because I know you can easily, that is based on cramming. It's not based, you are not thinking about anything. You just open the book, you look at the definition, you write it there. Or you go to Google, you look at the definition there, you like it there. Or you memorize it yourself and you write it there. So that's not the way we are doing it. We like to concept, the better way is to help you analyze and think and apply the concepts you're using. So to apply the concepts, we use these concepts in problem statements and in solving problems. And these are small problems. They are not difficult problems. They're metric level problems. Okay. So Newton's second law, we're familiar with Newton's second law, which is F is equal to ma, right? Now, we are using this law to solve this problem here, you can see. And in this case, for example, the statement is 1,000 kg car is accelerating from rest to 10 meters per second in 2 seconds. What force was applied to the car? So when you say a body is at rest, it means that the initial velocity was equal to 0. The final velocity is equal to 10 meters per second. This is given. And the time is given to be 2 seconds. And you have to find the force. F is equal to what? So what formula are you going to use? Again, in this book, VI is represented by U and VF is represented by V. So we have the value of U is equal to 0 meter per second. V is equal to 10 meter per second. And we have T is equal to 2 seconds. So what will we do? We have to find force. In order to find force, we can use Newton's second law, which is F is equal to ma, right? So if we find A, we already have the mass. So M is equal to 1,000 kg. So we have to find A. In order to find A, we have to identify a formula that will help us find A. So we have a formula that we studied a few pages back, which is VF is equal to VI plus AT. But again, according to the symbols in this book, this is V is equal to U plus AT. So A is equal to V minus U divided by T. So this is what you are putting here. The value of V is 10 minus 0 over 2. And you get your answer. You put this value of A in F is equal to ma and you find the force. Okay. So I'm going to stop here. And I would again advise you to practice this. And there's another thing I am reminding you, and that is your homework. Please prepare for the next upcoming assessments that we have. You remember these assessments? Okay. So prepare for assignment 2 and prepare for quiz 2. Okay.